atoms then of different elements are joined together in these repeating units we either call a molecule if it's a molecular compound or a formula unit if it's an ionic compound. So these chemical bonds that join these atoms together, these chemical bonds can either be a covalent chemical bond or an ionic chemical bond. Now, if it's a covalent chemical bond joining the atoms together, then electrons actually are being shared. Actually, at least a pair of electrons, if not more, are being shared in order to keep those atoms together. So I have an example here. I think this should work. Example of a covalent compound would be water. And I want to show you how, with those three atoms, how electrons are being shared. And we'll be talking even more about this, but let me kind of give you a precursor at what that looks like. So what I want to do, if it's okay with you, is there's my oxygen atom. Now, if you were to find oxygen on the periodic table, you would find it in 6A. Those X's around that oxygen atom actually represent the valence electrons. If it's a group A element like oxygen is, you know the number of valence electrons by the group number. So 6A group means 6 valence electrons. Looks like a football sort of thing, doesn't it? Okay, so how many electrons does a hydrogen atom have? A hydrogen atom has 1 electron. So let me go ahead and saddle those 2 hydrogens up to that oxygen. I'm going to show those then as little circles that each hydrogen brought to the table. So do you see here where a water molecule sort of looks like this, where actually there are 2 electrons being shared between the oxygen and the hydrogen. One came from the oxygen, one came from the hydrogen. Okay, so electrons are being shared. The electrons being shared create that covalent bond. Now down there at the bottom there, the HOH, okay, those dashes actually represent that what we call pair of electrons that are being shared there. So those are our covalent bonds. So I hope that helps. Let's take a look now at, see if this will work for me, at ionic bonds. So the example I brought in is the example for an ionic compound. One that's chosen quite often is actually table salt. So the formula for table salt, of course, is NaCl. See if this will work for me. Yeah, okay. Okay, so there's my ionic compound. I want to show you an example of a chemical bond that connects the Na and the Cl is an ionic chemical bond. Now the thing about ionic bonds is that we say an electron was transferred. And what we're going to see is that metals are great at wanting to give up an electron or 2, and nonmetals are great at taking in an electron or 2 or 3. So of course the metal here is sodium, and we're going to see how sodium kicks off an electron. It's kind of like that video we saw. So it's almost like a little story how this ionic bond forms. So the metal is going to kick off 1 electron. Now in this case sodium is going to kick it off and give it to chlorine. We're going to talk more about why that is. It's a mutually beneficial situation. So when sodium kicks off an electron, now it has 1 less electron than it used to have, so now it's a +1 charge. When chlorine takes in 1 electron, now actually it has 1 extra electron, and it's a -1 charge. That actually creates this kind of cool situation where they can be bonded together just simply by kind of electrostatic situation. So that is an ionic chemical bond right there. An electron was transferred to create that ionic chemical bond. If we were to show them kind of bonded together, I usually use ... for an ionic chemical bond for some reason, and a solid line for when electrons are shared with a covalent chemical bond. So that's what we mean when we say electrons are shared, like for instance with water, and electrons are transferred, for instance with sodium chloride. When they're shared, that's a covalent bond, and when they're transferred, that's an ionic bond. So now this next slide then says something else that you can add to your kind of tally-hoo. Okay, so remember, I'm just going to kind of remind you, we're kind of keeping a running class here, running whatever you call it. So molecular CPD and ionic CPD. So now what you can add is for ionic compounds, it has to have at least 1 ionic bond. So at least one ionic bond in the compound. As you can imagine, when compounds get complicated, ionic bond. When compounds get complicated, they have a lot of chemical bonds, and if at least one of those chemical bonds is ionic, then it's an ionic compound. So for molecular compounds, these chemical bonds must all be covalent chemical bonds. Okay, electrons are being shared all over the place. All right.